Alrighty, here we go. In this video, we're going to be discussing an angular velocity word problem. And this specific word problem will be angular velocity to linear speed. That's how we are going to convert and solve. First of all, let's get some definitions down, and then we'll go ahead and start solving this. Ignore that. Made a mistake last video. So here we go. The angular velocity, or the angular speed, is the speed at which an arc is being swept around a central angle. Now, the equation is going to be theta over time, theta being the central angle, and radians, very important, over a given time interval. So always remember, for angular velocity, that it is always going to be radians over the time interval. Always radians over the time interval for angular velocity. Now, linear speed is the speed of a point on the end of the ray that is swept out by the central angle. So v, or velocity, which is what the v stands for, equals s over t, s being the arc length in radians over the given time interval. You can also write it as the radius times theta over time, because s, which is the arc length, equals radius times theta. So always remember, for linear speed, it is always the measurement over time. So a measurement such as meters, kilometers, feet over time. Alrighty, on to the word problem. So wheels of a car have a radius of 0.86 meters. At full speed, the wheels turn at a rate of 117 revolutions per minute. What is the wheel's speed in radians per second? And then what is the speed of the tip of the wheel's edge in meters per second? All right, two different steps here. Going to start off with the angular speed, which again is theta over time. A lot easier to convert from these revolutions per minute to radians per second. So we start with what we're given, 117 revolutions per minute. Revolutions per minute, and we need to get rid of this minute because it wants it in second. So got it, top on bottom cancels out. So 1 minute over 60 seconds, we have our seconds. We can cross out our minutes. And now we need to get rid of this revolution. So how do we do that? So if you remember back to the unit circle, maybe you haven't gotten there yet, but 1 pi, or 1 radian, is 180 degrees. 2 pi is 360 degrees, and that would be a full revolution around the circle, or the wheel in this case. So a full revolution is going to be 2 pi radian. So 2 pi radian over 1 rev, cross out the revolutions, and you're left with radians over seconds. Put that in your calculator, solve it, and you'll get rounded 12.252 radians per second. Radians per second. You can't see that circle there. Alrighty. Anyway, now we're going to move on to the linear speed, which again is the velocity r times theta over the time interval. So r being the radius, what's the radius here? 0.86 meters. 0.86 meters. So we're going to do 0.86 meters times, what is our theta? So we just need to plug in our theta over time. Theta over time, just plug that bad boy in. So we're just going to plug in 12.252 radians per second right in there. Then we're going to just multiply that out, and you're going to get rounded 10.537 meters per second. And that will be your answer right there, ladies and gentlemen. That is your linear speed, and then your angular speed, or angular velocity.